Okay, let me give you guys some practice. So here, given a circular cone here, the formula for the volume of a circular cone is given by this. Now, I want to know what happens as we vary the volume of this cone here. What happens to the radius? Now, we're going to keep the height the same. So the height is constant. We are going to vary the volume and see what happens to the radius. The question is write down the relationship between the radius of this cone here and the volume. Okay. If you were if as it stands, if you were to isolate this radius here, so it becomes this here. Hang on, v equals pi h over 3, and then, well, if you were to pull out that r squared here, it will become this. Now, if you were to call this k, you see what's happening here is that you've got this. So what it's telling you is that as you vary the radius, you're seeing what effect it will have on the volume here. You see, you are varying r, and you are seeing what effect it will have on the volume of this cone here. But I don't want that. I want to know what happens to the radius as we vary the volume here. So you see, at the moment you've got volume equals blah 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 r. So what it's saying is that as you're changing r, you are seeing what's happening to the volume. I want to know what happens to the radius as we change the volume here. Okay, so basically you've got to rearrange this. Okay, so the first part of the question is what is the relationship between the radius and the volume? Okay, maybe it's radius is proportional to I don't know, to the volume squared maybe. Well, your job is to come up with the relationship between r and v. Okay, and also the second part of the question is what happens if we keep the height the same, but then we double the volume. So here, this one here has a volume of v, this here has a volume of 2v. What happens to the radius? How much? So this new radius here, how much does it grow by? So what's the scale factor here? So you see, when we times the volume by 2, what do we times the radius by? Okay, so that's the second part of the question. The first part is write down the relationship between the radius and the volume. Okay, so press pause and have a go. Okay, start off with rearrange this to make r the subject. So times both sides by 3, so you will have this r squared h, and then divide both sides by pi h. So this will be 3v over pi h equals r squared, and then square root both sides. So this will be this thing here, 3v over pi h here equals r. Now I'm just going to switch the two sides around. R equals this here, 3v over pi h. Okay. Now we've got a formula so that we can see what happens as we change v. So we can see what effects that will have on the radius. So we're varying v and see what effects it will have on the radius. So our job is to isolate this v here. Okay, so now using indices, indices. So when you have this here, square root a b, this equals root a over root b. Now, if you don't understand this, you have to watch one of the videos on indices. So now this, I'm going to use this property up here. Okay, I'm going to use it as this, root 3v over root pi h. Okay, so now I'm going to use the other property of indices. When you have this here, this becomes root a root b. So I'm going to use this for the top one here. I could do the same down here, but I don't really care about pi and h. I only care about v at the moment. I'm trying to isolate the v here. So using this here, I'm going to use it for the top part. So it's going to be root 3 root v And then I could do the same here. Okay, I'll do it, but it's pointless, wasted energy here. So here you can imagine this as being this times this here. Now pull this out here. Okay, so it will be this. Hang on. It will be this here. Hang on. Root 3 over root pi root h and then times root v. Okay, so here we've got radius equals this, radius equals this, radius equals this. Now this whole thing here is just a constant. We don't really care about anything in here. That's why I said this. Anyway, we don't really care about anything in this bubble here. So let's just give it a new name, a new constant. Let's just call it k. Okay. So this here, you've got this. So you've got the radius equals k times root v. Now once you're here, you can actually make the statement that the radius is proportional to the square root of the volume. Okay. So after all that there, when you've got a circular cone here, the radius is proportional to the square root of the volume. So once we know this, we can answer the second part of the question. Hang on. So going back to here, let me just clear up everything. Going back to here, we know that the radius is equal to k square root of v. Okay, so you can actually say well, the answer to this first part of the question, the relationship, you can say the relationship is proportional to the square root of the volume. Now, starting to answer the second part of the question, what happens when we double the volume, keeping the height the same? So this here has a volume of v, this here has a volume of 2v. What happens to the radius? Okay, how does this radius compare to this radius here? Okay, so now let's look at this system here. Now this system here has a radius of this. Okay, now let's look at this system here. So our new radius, our new radius, let's call it radius nu here, equals k and then a root. Now our volume here is 2v, so we've got to put this into this formula here. So the old formula is basically k root v, but our volume here, our new volume here, is twice the volume of the old one. So we've got to put 2v in here. Okay, so the radius of the radius of the old volume here is given by this. The radius of the new one is given by this here. Notice that we've got 2v in here because it's twice the volume. Now we want to well, let's break this up by using that by using root a here equals root a times root b. So let's use that on the 2v. So this becomes k root 2 times root v. Okay, but the thing is, so this is the radius, our new radius, the radius of our new volume here, of this volume here. Now we want to write this thing here in terms of the old volume. So you see so what am I talking about? Sorry, in terms of the old radius. Okay, so here, hang on, sorry, this here is the radius of this one here. Now this here, this here is the radius of the small volume here. We want to write the radius of the new one in terms of the old radius. You see what I mean later on. Hang on. So at the moment, our new radius is this times this here. Let's move this in front and put the k in the middle. So it would be this. It would be root 2 times k and then times root v. Now you see our new radius is root 2 times k root v. You see this here is our old radius. You see you see our old radius is k root v. Now this here, what we've done is we've expressed the new radius in terms of the old radius here. This is why when you were here, well, this is why when we were here, we wanted to express this whole thing here in terms of the old radius. So we broke up this thing here. So it's like this, and then express now. Well, what we've done is we've expressed a new radius in terms of the old radius. So what you can see is that the new radius here is going to be root 2 times bigger than the old radius. You see, this is the old radius here. Well, if you get a calculator and do root 2, it's going to be 1 point what? Hang on, calculator. 1.41. Well, this root. Well, if you square root 2, it's going to be this. You see, the new radius is going to be 1.41 times bigger than the old radius. Okay, k root v. So what this means is that when you double, hang on, what this means is when you double the volume here, the radius will grow by 1.41. Okay, yeah, so we can check that out. So the radius will grow by root 2 basically. Well, let's yeah, okay. Well, actually, you can check it out by putting some values in here. Hang on. So here, let's just set the height to be anything. I chose 4. You could choose 5. Whatever, 3, whatever. The volume, I'm going to say 10. Well, if this has a volume of 10 centimeters cube, it could be anything. You can set up anything. You could say it's 20 or whatever. I just chose 4 and 10. Now, if this is 10, because we are doubling it, this must be 20. Okay. So this has a volume of 10. This has a volume of 20. Now let's see if it truly grows by root 2. Let's see if the radius actually grows by root 2. Okay. So hang on. So starting with this formula here, this is the h here. Put it into here. This is the volume here. Put it into here. So basically, work out the radius of this and work out the radius of this when it has a volume of 20. So once you've got the two, once you've worked out this radius, once you've worked out this radius, you can work out the scale factor that would take you from the old radius to the new one. Okay. Well, anyway, follow it through here. Okay. So the radius of the big cone would be this. The radius of the small cone would be this. Now, if you get this divided by this, that will give you the scale factor. So basically, the scale factor is 1.41. Well, what I'm trying to say is that once you've got this radius here, get this radius new. Well, from here you want to find out what number that would take you from here to here. So you would get this radius divided by this. So that's what we've done down here. Okay, so we've got the radius of the new radius divided by the old radius, and it gives you this. Now this number here is actually root 2. So it does tally up with what we worked out earlier. Okay.